Here we have problem 3, a momentum in an explosion. So we have a giant egg, okay, that explodes as part of a fireworks display. Okay, the egg is at rest before the explosion, and after the explosion, it breaks into 2 pieces. Piece B moving in the positive x direction. The masses of both pieces are indicated in figure 1, showing traveling in opposite directions. Okay, so we have the 2 pieces here. There's an explosion. One of them shoots to the right, the other one shoots to the left. Piece A weighs 10 kilograms and piece B weighs 30 kilograms. Okay, now their momentum, okay, one is going to be in the negative direction and one in the positive direction. But according to the momentum theory, the negative magnitude momentum is equal to the opposite of the opposite momentum. So the first question says, what is the magnitude of the momentum PAI of piece A before the explosion? Express your answer. So we have the momentum, right? So before the explosion, there's no momentum. So momentum is 0, since velocity is 0. Okay? Weight times velocity. So we have 0 as part A. So A, okay, the momentum, which is going to be written in forms of P, okay, PA, I, is just going to be 0 kilograms times meters per second. Okay. And then for part B, we are told, let's see, part B. During the explosion, is the magnitude of the force of piece A on piece B greater than, less than, or equal to the magnitude of force of piece B on piece A? So here they are, piece A and piece B. The force, and they're asking for, what are they asking for again? Let's see. Is the magnitude of the force of piece A greater than, less than, or equal to the magnitude of force of piece B on piece A? Well, the force is just going to be the velocity, right, times the, how do I say this? I know the weight is not involved. So even though this one is 10 kilograms and this one is 30 kilograms, the force acted on this with this compared to this on this is the same, okay? And then the force of explosion, which we're going to get to in a later section, even though the weights are different, the quantities of the explosion are the same, but in opposite directions. So they're the same force, or they're equal to. So for B, the forces are equal, see? So P, we can write it in P form. So P of A, right? Force of A, right? Force A, yeah. Here's another way to put it, force. I have a better way of writing it. So force FA on B equals FB on A, and this almost reminds me of the third law of Newton's third law of motion. Okay, so they're equal because it's inside of a system. There are no forces acting outside. It's so because they're equal. Okay, and then for part C, see what it says here. The component of the momentum of piece B, PBX of F, okay, is measured to be 500 kilograms after the explosion, meters per second. Find the component of the momentum. Well, momentum has to be the opposite, so it has to be negative 500 kilograms per second. So PAX. So PAX, PAX of I is gonna be equal to the inverse, right? The inverse of PBX, right? The inverse of PBX. So that is just equal to negative 500 kilogram times meters per second. And that, I believe, is the end of this problem. Hold on, it gets blurry here for a second. Yeah, so that's the end of this problem.